Good morning. Here I have come with a new topic, law of constant proportions. Okay. Last day means just yesterday a topic was discussed. The topic was law of conservation of mass. Here in this chapter you have to learn five laws are there. Okay, where the first four laws are related to mass of the substance, and the last one, that is called Gay-Lussac's law. Gay-Lussac's law of gaseous substances. There, that law is related to volume. So first law was related to law of constant proportions. Okay. What is that law? Law of constant proportions. The law is like that. A pure compound, a pure chemical compound, not only compound, a pure chemical compound always consists of same elements. First thing is what? Same elements. A pure chemical compound always consists of same elements in the same definite or constant proportions by mass. Okay. So proportion proportion remains constant. As for example, if I take, say, this example, ethyl alcohol, this is ethyl alcohol, C2H5OH. If you take ethyl alcohol from any source, if you take ethyl alcohol from any source, and if you conduct experiment to find the proportions of the masses of carbon, hydrogen and oxygen, then always you will get the ratio to be 12:3:8. Similarly, if you take water from any source, you always get the ratio of hydrogen and oxygen to be 2:16, that is 1:8. Okay. So this law is called what? This law is called law of constant proportions. Okay. The proportion remains constant, it does not vary. So that is the law. So for most of the compounds, for most of the chemical compounds, you will find that this law holds good. Means this law is valid. Okay. For most of the compounds. But there are also exceptions of this law. Okay, there are exceptions. Now I am talking about the exceptions. Okay, let me explain the law first. Suppose AB, okay, I am writing here. AB, this is what? This is a chemical compound. Okay, suppose AB is a chemical compound, and the elements present in the compound are A and B. A and B are the chemical compounds. So suppose you have adopted one method of preparation. You have adopted one method of preparation for the formation of AB, and the ratio of the substances A and B was X:Y. Can you see? X:Y. Okay. This was the ratio for a method of preparation. Okay. And now you are going to prepare the same compound, same chemical compound AB by using another method. And by using another method, the ratio of the masses was, suppose, M:N. Okay, M:N. That is the ratio. Okay, that is the ratio for another method of preparation for the same chemical compound AB. Okay, so if you do experiment, if you have the numerical data for X, Y and M and N, then you will find that X:Y is equal to M:N. You will find that. this. X is to y is equal to m is to n, and this is the law of constant proportions. Okay, here in this experiment, the method of preparations for the two cases were different. Okay, still you have got the same ratio, and ratio of what? Not ratio of volumes, it is ratio of masses of the substances. Okay, now I am talking about converse of the law, means just opposite of the law. What should be the opposite of the law? Means if the elements, okay, by which the compound is made, chemical compound is made, if the elements are in the same ratio, okay, by mass, then the compound formed by them will be always same, and that is not true always. That is not always true. Okay, if ratios are same, then the compound will be same. That is not true. So, for example, I have taken ethyl alcohol and dimethyl ether. This is dimethyl ether. Ethyl alcohol, this is denoted by C2H5OH, and dimethyl ether, this is denoted by CH3OCH3. Here you can find that number of carbon atoms is 2, number of hydrogen atoms is 6, 5 plus 1, 6, and number of oxygen atom is 1. And if you take the ratio of masses of carbon, hydrogen and oxygen, you will get 12 is to 3 is to 8. This is carbon, this is hydrogen, this is oxygen. The ratio will be 12 is to 3 is to 8. And if you take another chemical substance, another chemical compound, which is here dimethyl ether, in that case, here also number of carbon atoms is how much? C means 2, 3 means 6, and O 1. Okay, so number of atoms are same as ethyl alcohol. So here also the mass ratio is 12 is to 3 is to 8. So for both the chemical compounds, the mass ratios are same. For both the chemical compounds, we can see that mass ratios are same. Mass ratios of what? Mass ratios of carbon, hydrogen and oxygen. They are same, and the ratio is 12 is to 3 is to 8. But we know that both the chemical compounds are totally different. They are absolutely different. Okay, chemical properties of both the compounds are different. They are different chemical compounds. So this is converse of the law. Okay. Then in case of polymerization, means if you talk about monomers and polymers, as for example C2H2, this is what? This is acetylene, and C6H6 is what? It is benzene. So here on polymerization of acetylene, it gives what? It gives benzene. On polymerization of acetylene, we get benzene. Okay, and we know that both the chemical compounds are totally different. Chemical properties of both the compounds are totally different. Okay, there is no similarity between the properties of the two chemical compounds, acetylene and benzene. Right, here you can see that ratio of, here how much carbon is there? Number of atoms. If you talk about number of atoms, then it is 2 is to 2, that is 1 is to 1. And here 6 is to 6, that is 1 is to 1. So if you take mass ratio, then you will get always same. For acetylene, what should be the mass ratio? For acetylene, the mass ratio should be 12 into 2 and 1 into 2. Means 12 is to 1. Right? 12 into 2 and here 1 into 2. So if you take the ratio, then it becomes 12 is to 1. Here 12 into 6 and 1 into 6 means again 12 is to 1. So we can see that mass ratios for acetylene and benzene remain same. And on polymerization of acetylene, it gives benzene, it produces benzene. But both the chemical compounds are totally different. So this is also converse of the law. Okay. And now again one more example can be taken. for the converse of the law, that is urea and ammonium cyanate. Formula for urea is NH2CO NH2 and formula for ammonium cyanate is NH4CNO. Here, if you take the mass ratios of carbon, hydrogen, nitrogen and oxygen, you will get for urea you will get 12:4:28:16, and for ammonium cyanate also you will get the same ratio 12:4:28:16. So mass ratios are same, but the chemical substances, chemical compounds are totally different. So this is also converse of the law. Converse of the law of constant proportions. Now, next topic is limitations. Yes, this law has also some limitations. If you take the example of cuprous sulfide, okay, if you take the example of cuprous sulfide, then from various sources, if you do experiment, if you conduct experiment, then you will find that the formula for cuprous sulfide varies from Cu 1.7S to Cu2S. It varies. Okay, the formula varies for cuprous sulfide if you collect cuprous sulfide from different sources. And again, if you take another example of, I have taken here an example of titanium oxide. So here you can see the formula varies from Ti.750 to TiO.69. So since formulae are different, therefore mass ratios must be different. Okay, mass ratios do not remain same. Okay, so this is the limitation. Again, if you talk about these isotopes, okay, if you talk about isotopes, then also say we have taken the example of carbon dioxide. You know that carbon dioxide has two isotopes. One is C12 and another one is C14. So if isotopes, the two isotopes are used to form carbon dioxide, then for C12, okay, for that isotope, the mass ratios will be 12:32. Here 2 is there, O2. So 16:2, that is 16 into 2, that is 32. And for C it is 12. It is C12 isotope. Okay. And for the other isotope C14, the ratio will be what? 14 into 2 into 16. That is 14:32. So we can see that here ratios are different. Okay. For isotopes, ratios are different, 12:32, and here it is 14:32. So mass ratios are different. It is for isotopes. So this is limitation of the law. Okay. So this was all about law of constant proportions. Okay. Next topic will be posted in my next video, and that law is law of multiple proportions. Okay. Thank you for watching this video. Have a nice day.